Okay, this lesson will be focusing on rhesus incompatibility and haemolytic disease of a newborn. When we speak of rhesus incompatibility, we are going to be considering specifically the D antigen. And what we need to know about the D antigen is the D antigen is very much important in as much as blood transfusion and transfusion reaction is concerned in the rhesus system. And unlike other antigens in the ABO system that occur in the blood plasma or are present in the blood plasma, with the rhesus antigen, the D antigen is present on the surface of the red blood cell. So if this is our red blood cell, the D antigen, these proteins will be present on the surface of our red blood cell. So this is a rhesus positive individual. So a rhesus positive individual is an individual who has the rhesus antigens on the surface of his or her red blood cell. So a rhesus negative individual is an individual who does not have the rhesus antigens on the surface of his or her red blood cells. So what happens if peradventure blood from a rhesus positive individual gets into a rhesus negative individual? What happens is that this individual's body is sensitized to produce the immunoglobulin antibodies, the IgG antibodies. The IgG antibodies are not naturally occurring. They would only come into play when the individual is sensitized. The IgG antibodies, they are Y-shaped and they are found in the blood plasma. So if this person happens to receive, this person who is rhesus negative, happens to receive blood from a rhesus positive individual, probably during childbirth or during a blood transfusion, this person's system will be sensitized to produce the immunoglobulin antibodies. So that is a normal physiological pathway. So we are now looking at a condition where we permit me to wipe what I've already scratched on the board. So we are looking at a condition where there is a mother who is rhesus negative and a father who is rhesus positive. That is a probable, or that is the scenario from which we would get the condition of haemolytic disease of a newborn. So haemolytic disease of a fetus or a newborn is that condition wherein we have our mother who is rhesus negative and the father is rhesus positive. Due to the genetic makeup of the father, the child or the fetus have a likelihood 50 or 100% to be rhesus positive. So if this infant or this fetus happens to be rhesus positive, this fetus happens to be rhesus positive as a result of the father's genetic makeup, what would happen is during intrauterine life, during the latter pregnancy, there is a tendency of fetal hemorrhage or a condition where fetal blood leaks into maternal circulation during the later trimester or during delivery. It is very, very much a very high tendency, or it's normal, that part of the fetal blood is normally supposed to leak into maternal circulation. So once that happens, we get now to the condition in the second pregnancy. In the second pregnancy, where the fetus still happens to be rhesus positive. Obviously, our mother is a rhesus negative mother. So the fetus happens to be rhesus positive and the mother is still rhesus negative. During the first pregnancy, after delivery, the mother's system will be sensitized to produce the IgG antibodies, the immunoglobulin antibodies. The immunoglobulin antibodies, as we have earlier said, they are Y-shaped. So due to the sensitization, these antibodies would now be present in maternal circulation. So let's look at it at the level now of the second pregnancy. So these antibodies would now be present in maternal circulation. So during the process of passive immunity, that process is a process whereby some of the immunity of the mother, or some of the antibodies actually of the mother, have been transferred to the fetus. The antibodies are normally supposed to be transferred to help the fetus to be able to fight infections in later life as it grows up and all those things. So as the antibodies are being transferred, the IgG antibodies, some also will be transferred into the fetus. So what happens is these antibodies, as they are transferred into the fetus, during this process, these antibodies are transferred into the fetus. Let me use another color ink. As they are transferred into the fetus, what happens is that as they get into the circulation of the fetus, as these IgG antibodies get into circulation, as a result of this rhesus antigen, they begin to agglutinate the blood and hemolysis takes place. They agglutinate the blood cells, the red blood cells, and lysis, they kill the red blood cells, what is known as hemolysis, is destruction of the red blood cells. And as hemolysis takes place in the fetus, what happens? A lot of red blood cells will be destroyed, the blood cells will be destroyed in the fetus. And as those red blood cells are being destroyed, the fetus now has a tendency or a likelihood to become anemic. So as the fetus becomes anemic, what happens is the fetus now, the organs in the fetus that are responsible for the production of red blood cells, we have basically the spleen and the liver. So the spleen and the liver now will speed up to produce more red blood cells to compensate for the damage that is naturally occurring. So as the spleen and the liver produces a lot of red blood cells and it overworks, there is a tendency for the spleen to enlarge, and the liver also enlarges. That is what is known as hepatomegaly and splenomegaly. That is a condition that this fetus is bound to suffer from. And also, due to the breakdown, excessive breakdown of the red blood cells, as the red blood cells are being broken down, the hemoglobin that is being broken down in the red blood cells, the end product of hemoglobin is bilirubin. The bilirubin is toxic to the brain tissues. So this child, as the bilirubin, that excessive amount of bilirubin is bound to affect the brain of the child. As it affects the brain of the fetus, we realize that in later life, if this fetus goes through gestation and is delivered, there is a tendency of having brain defects as a result of that developmental process that was affected as a result of excess bilirubin. Then also, the heart also is bound to work abnormally, to pump faster to compensate, because as a result of limited hemoglobin in blood, which is as a result of destruction of the red blood cells, there will be limited oxygen carrying capacity. So to compensate for that, the heart will pump faster. So if in some scenarios the heart can even lead to heart failure, because the heart will work abnormally more than its capacity. So those are probable things that would happen. We have spoken of hepatomegaly, splenomegaly, we have spoken of brain defect, we have spoken of cardiac failure, which is a probable cause that can lead to stillbirth in this condition. So just like it's normally been said, that prevention is better than cure. We have already seen what this child is bound to suffer from: hepatomegaly, splenomegaly, cardiac problems with brain defects. So how do we prevent this condition from occurring? Immediately after birth, what is normally supposed to be done based on the hospital policy, either during the after 38 weeks of complete gestation, the anti-D antibody, that is the immunoglobulin G antibody, the immunoglobulin G antibody would be administered to the mother. The anti-D antibody, what it does, as the anti-D antibody is administered into the mother, it mops out. Let's go back to this first example. This is the first pregnancy. As a fetal blood leaks into maternal circulation, this fetus is being delivered. If we administer the anti-D, what the anti-D does, it gets into the mother's system, it mops out all of the rhesus antigens that are present in maternal circulation, to ensure that in a subsequent pregnancy, the mother does not have these rhesus antibodies present in the mother's circulation. So this is the pathophysiology of haemolytic disease of the newborn. I'll see you in our next video. Thank you. Just do well to subscribe to the channel to learn more.